Welcome to The Explainer. Today, we're tackling what is, honestly, probably one of the most maddening problems in AI development right now. If you've been building or even just working with AI agents, you know exactly what I mean. You spin up an agent, it starts off super smart, right? But as the session drags on, its memory just completely falls apart. Well, today, we are looking at the actual solution to this, Perl version 8.0.
Right now, the whole AI industry is caught right in the middle of what the official documentation literally calls a token apocalypse. Because coding agents default to stuffing entire massive chat histories into these giant context windows, right? And what happens? You rack up exorbitant API costs and your agent suffers from this brutal, lost-in-the-middle context collapse. It constantly forgets past lessons. It's like it has this sort of Groundhog Day amnesia where it just makes the exact same mistakes over and over and over again.
All right, here's our game plan for today. Surviving the AI token apocalypse, the Agentic Memory stack, the mechanics of thought, the discovery engines, and securing the hive mind. Let's dive right in.
Part 1. Surviving the AI token apocalypse and breaking that loop.
The big concept to grab onto here is that Perl is a budgeted inference amortization engine. The whole goal is to completely scrap that chaotic, giant prompt approach. So instead of treating memory like this messy, homogeneous blob of text that you just dump into a prompt and cross your fingers, Perl treats it as structured, verifiable, agentic memory.
Let's really contrast these two approaches because it's night and day. On one hand, you have context window stuffing. It's wildly expensive. It forces the AI to basically reread its entire life story every single turn, and it loses crucial details in all that noise. But then you have the Perl inference amortization engine. Perl stores a strict, verifiable history completely outside the prompt. It compresses the older, cooled-down history into dense notation, and then it elegantly injects only the budgeted, hyper-relevant shards that the agent actually needs for the exact task it's doing right now.
Moving to Part 2, the peer memory stack. This is a highly disciplined architecture.
To really wrap our heads around this, we are going straight to the source, diving into the official version 8.0 reference manual to see exactly how these memory layers interact with each other.
The manual outlines a really strict four-tier hierarchy. Layer 1 is canonical episodic memory. This is your absolute foundation, the immutable, undeniable raw facts of what actually happened. Layer 2 is the enterprise knowledge graph, which takes those facts and maps out structural connections. Layer 3 is guarded distilled memory, which they call déjà vu. This extracts the abstract patterns and priors. And finally, Layer 4 contains the version 8.0 overlays, which handles semantic ledgers, deterministic tools, and governance.
Now this specific design order, it's completely non-negotiable. You always start with Perl first, those canonical raw facts, then you notate to compress the warm layers. Only after that do you derive your knowledge graph. Déjà vu is distilled third, and it comes exclusively from that graph. Overlays come last. The absolute key takeaway here is that you can never reverse this order. You never want an AI hallucinating a pattern before it actually has the cold, hard facts.
Which brings us to basically the golden rule of this entire ecosystem. If it is not in a PRA, it did not happen. Period. I love this because it perfectly illustrates that PRA is an incredibly strict epistemological ledger. It completely forces the AI to ground everything it thinks it knows in traceable local evidence.
Section 3, the mechanics of thought, powered by the PeerLisp engine.
So under the hood, version 8.0 runs on what's called PeerLisp. The documentation describes this as a homoiconic common Lisp cognitive engine. If we translate that tech jargon into plain English, it just means the entire memory lattice self-assembles using incredibly simple, elegant building blocks. It makes the engine beautifully efficient at compressing and reasoning over its memory.
It all boils down to these three foundational primitives. Notice acts like a basic atom. It perceives a signal from the static to create an observation. Relate binds two pearls together, actually building out those structural connections. And doubt is the ultimate gatekeeper, evaluating the memory to decide, hey, does this survive or does this dissolve?
I really want to zero in on that doubt primitive for a second. It's such a brilliant, aggressive defense mechanism. Before any piece of information is allowed to become durable memory, it has to pass through the doubt gate. This is exactly how this system actively defends itself against AI hallucinations, weak evidence, and useless marketing fluff.
Part 4, the discovery engines, and what we get upgrading to v8.0. Version 8.0 introduces three massive native engines. First is statistics, which catches and verifies numbers, citations, and quantified claims. Second is synchronicity, which is this context collision algorithm that engineers brilliant connections between totally disparate shards of memory. And third is superfugu, providing this incredibly cheap tiered hybrid retrieval over cold memory, so you don't have to load the whole massive archive every time.
Let's look at the core rule for the statistics engine. Sniff broadly, store carefully, doubt aggressively. You guys, statistics is ruthless. It demands denominators and dates. So if an agent tries to store a vague claim like, oh, 42% of users prefer this, statistics will immediately hit it with a doubt gate, demanding 42% of what? When? It flat out rejects weak numbers from ever becoming factual evidence.
And here is how these engines compose together into one seamless loop. Superfugu warms up the relevant candidates while keeping the vast majority of the archive cold and cheap. Synchronicity collides those candidates together to find non-obvious opportunities. Then, statistics steps in, checks the evidence, and sends out ghostball requests if sources are missing. Finally, Pearl writes the verified output back as new candidate layers. It's a completely closed, self-verifying loop.
Finally, Section 5, Securing the Hive Mind with Enterprise Vaults. This brings up a really tricky problem. When you have multiple AI agents working in parallel across an enterprise, physical clocks get super messy. That's where temporal brokerage comes in. Instead of trying to force one true universal time, it settles shared history directly within Pearl. It acts as an append-only ledger that explicitly tracks uncertainty, which completely prevents chaotic conflicts between all your different agents.
When we look at how the encrypted Pearl Vault is set up, the crucial takeaway is the security boundary. The server only ever stores ciphertext and quota manifests. All the actual decryption happens strictly locally, right on your device.
Getting an agent or a device connected is super locked down. You issue a server access key, and each device gets its own tightly controlled key, shown exactly once. This means if a single device gets compromised or you retire it, you can instantly revoke its specific access to the hive mind without losing any of your vault data. It's incredibly secure.
Wrapping up the enterprise side, Perl version 8.0 is essentially a fortress of truth for distributed teams. It uses atomic rights and session locking so concurrent agents can never corrupt the chain. It gives you a full audit console, a compliance engine so every piece of evidence is traceable, and centralized fleet governance to make absolutely sure every agent is operating within your organization's strict policy limits.
Which leaves us with a pretty big question to ponder. Right now, yeah, your AI agent can generate code, but can it actually build compounding wisdom? With Perl, search simply surfaces the candidates, but what will your Perl actually decide survives that doubt gate to become durable truth? It's a fundamentally new way to think about agentic memory, and I hope this explainer helped you see exactly why version 8.0 is such a massive game changer.